All right, for matrix equations, we're going to apply all of the skills from the previous lesson. All right, so everything that we did on the previous lesson with adding and subtracting matrices, as well as multiplying matrices by a scalar and multiplying two matrices, it applies to this lesson. The only difference is now we're going to be, our elements of the matrix will be expressions rather than numbers, integers. All right, so for the first example, we've got this. The first matrix is a 3 by 1 matrix, plus another 3 by 1 matrix, plus another 3 by 1 matrix. So we're going to add the top element from each one of the matrices. When we add the top element from each matrix, we'll be left with Q plus 3. Make sure that you write all of your expressions in descending exponential order. Make sure that your variables are in alphabetical order also. All right, so if you have more than one variable on each one of the terms, put the variables in alphabetical order, and you want your terms in descending exponential order. All right, so when we added the top element of the second matrix to the top element of the third matrix, 6Q minus 5Q gave us the 1Q. All right, so rather than write 3 plus Q in descending exponential order, it would be correctly written Q plus 3. When we add the second element in each matrix, there are no like terms that we can combine, so we just write all 4 of those terms in descending exponential order. Negative 3p squared plus PR. Notice I wrote the PR not as RP, I wrote it as PR in alphabetical order, plus R minus 3. And then for the last element in that expression in the matrices, whenever I add the last elements of each one of those matrices, I get negative 2 plus 2R plus RQ, which I write as QR. Again, we want to put the variables in alphabetical order. And there are no like terms there, so all I can do is just write each one of the terms out. So 2R plus QR minus 2 is what I should have for that third element of our answer matrix. All right, now we're going to multiply this 4 by 1 matrix by the scalar 5z. 5z times the 2y will give us our first element, 10yz. 5z times 2x plus 5 will give us our second element, 10xz plus 25z. Multiplying 5z times the third element in our matrix will give us 5yz plus 25z. And then 5z times the last element in the matrix will give us negative 20yz. Again, make sure to write your variables in alphabetical order. All the terms should be in descending exponential order. All right, next example, we're multiplying these two matrices. All right, so we're going to take the first row of the first matrix and multiply it by both columns of the second matrix. This is what the first row, first column should look like. And then when we multiply the first row of the first matrix by the second column of the second matrix, we'll get the following expression. Then we head down to the second row of the first matrix, multiply that by the first column of the second matrix, and we should get the following. And then again, that second row of the first matrix times the second column of the second matrix will give us this expression. And then once we simplify our answers and write the variables in alphabetical order, all the terms in descending exponential order, we should get the following matrix. Notice also our first matrix in the problem was a 2 by 3 matrix. The second matrix is a 3 by 2. The middle numbers are the same, so that's what allowed us to multiply those two matrices. And the resulting matrix was the outer dimensions, a 2 by 2.